Okay, in this video we're going to look at annuities. Now annuities are actually classified as anything where there are payments made at equal intervals. So that can be payments from the bank to the person, or from somewhere to the person, or from a person, an individual, to somewhere else. So for example, you could be making deposits into a savings account. You could be paying mortgage payments monthly. You could be doing insurance payments. You could be receiving pension payments. So anything where there's a regular frequency of payment. Now, particularly this time, we're going to focus on annuities which we use for our retirement. So a lot of you would have heard of a superannuation, or a super, the Australian Super Fund. So what this is a way of ensuring that people have money when they're retired, so that they can keep living and keep affording things once they're no longer earning regular money. So initially, during the course of your career, you'll be saving money. So that's what this looks like. Okay, and gradually this goes up in a kind of increasing gradient, and that's a compound interest kind of effect. So that's what happens when you're saving. Okay, and eventually you'll reach a point where you think you've got enough money, and that's when you retire. So obviously people want to retire as early as they can, because they want to enjoy as much of the time that they've got in their older age as they can. So ideally people would like to retire by sort of 60, 65 these days, or it can be even up to sort of 70 or above, depending on the person. So once you reach that point, you start to spend the money. Now the money doesn't go down in a straight line, because remember, the money earns interest over time. So it actually goes down in a curve like this. Now, what that means is that it goes down quicker at the end than it does at the beginning. At the beginning, the interest that you gain every month is enough to keep the fund as full as possible. Okay, so actually over time, as the amount in the account decreases, the amount of interest each time will decrease. So if you take out the same payment every time, so this dark green one here is the amount of money that the person's withdrawing every month or so. If you take out that set amount, it means that if you get the interest and you minus the withdrawal, that's what you get as the change. Okay, now when you're spending the money, the withdrawal will be bigger than the interest. Okay, the money that you take out will be slightly bigger than the interest earned. And so gradually, the change will get more and more as the withdrawal gets bigger in comparison to the interest earned. So let's just actually have a look at how this works in a question. So an annuity investment of $60,000 is earning interest of 4.8% adjusted monthly. And each month a value of $500 is also added. So this is what would happen if someone's saving up for their retirement. So you can see here an amortization table to show what's going on. So you've got 60,000 as your first amount. The interest earned on that would be 240. The payment would be 500, and so the new balance is this. So this is why it's exponential, is because obviously the interest plus, here we've got the interest plus the payment to give the change every time. So you're just adding on both at that point when you're saving. So now we're going to find out the rest. So this is a bit like amortization tables. We're going to get the 4.8%, and that's annually. And so we're going to divide that by 12 times 100 to get it as a decimal, and as 1/12 of that, because it's going to be monthly. So that equals 0.4 over 100, which is 0.004 as a decimal. So that's what we're going to times by the balance at the end of each month. So we're going to get 60740 times 0.004 to give us the interest of the second month. Okay, so that's the first month done. You can see we've added on both. We've added the interest and we've added the payment. And so the new balance is that, and that's what gets carried over to the next calculation for interest. So we get the new amount there, and we times by the fraction of the 4.8% as a decimal, and that will give us the new month. And we're going to carry on and do that for the whole table now. Final answer is actually 1 off, so we need to change that final answer there because of the rounding on each step that's happened. So if we were to just use Finance Solver, it would have come up as 0.71, and that's because it wouldn't have had to round each step. Okay, so once you've done that, it's asking us to create a recurrence relation for the example. So remember, recurrence relations start with your V0 amount, which is 60,000, and then your Vn plus 1, so that's how to get to the next step. You're going to times by, so Vn times 1.004. Now, we're doing it by 1.004 so we can just increase it in one step. So we don't have to times by 0.004 and then add the original. We can just do it in one step, which you know from previous topics. And then do that, add 500. Now, that won't allow you to work out the interest individually each time, but what it will do is go straight from this, okay, that's like Vn, it'll go straight to Vn plus 1, okay, by times them by 1.004, that takes care of this column, and then adding 500. Okay, so that's the recurrence relation there. Now, after 20 years of saving, $500 per month, the investor retires. So this is what happens at the end of the investment, and starts withdrawing money from the investment. This plan, they plan to take these payments for 30 years, so it's a 30-year retirement. They save for 20 years doing the $500 a month thing. If the interest rate remains at 4.8, what's the maximum monthly payment they can withdraw? So how much can they take out a month if they're using that money for 30 years? So first things first is to work out where they got to in 20 years. So let's start with the 20-year calculation, how much they're going to save. So it's 20 times 12, interest rate of 4.8, a starting value of 60,000. Now this has to be negative, and I'll talk about that in a sec. Payments, they made negative 500, so they put money in. And the FV, we don't know. That's what we're putting in as a question, and this is a monthly situation. Now, the reason that they're negative is because in this situation we've got the individual, okay, like the investor, we'll call them an investor, okay, there they are. They are transferring money into the fund, okay, so that's where you get the PV and you get the PMTs going in this situation during the saving part, okay, and we'll talk about how that changes later on. So let's work out what that future value is. So we're going to go menu Finance Solver. This is 20 times 12. This is 4.8. This is negative 60,000. This is negative 500. This is no. And now you just press enter there. We get 357239. Okay, so that's quite a bit of money. It's not huge, but it's enough. And you'll notice that that's positive now because that's owing back to the person. Okay, that's owing to the investor afterwards. So it's sort of sat in the fund waiting to come back. Okay, so that's how much is achieved by that stage. Now, what we now need to do is talk about so this is for the savings we just talked about. This is while saving. And then the next bit is during the retirement. So now what's happening is the fund is transferring the money back to the investor, and they're doing it in regular payments. And that's what we don't know what that is, because we need to know how long they're going to take that money for. So N is going to be for 30 years this time, so 30 lots of 12, 4.8% interest. The PV is the amount of money that we got to, and it's negative because it's in the fund at the moment. Okay, PMT is unknown. FV is 0, because we're going to run the fund right down to 0. That's the idea. So the person's retirement will end at 30 years. Hopefully it lasts, the right amount of time. Otherwise, you'd expect them to sort of have more savings in other places, more investments. So that's going to allow us to work out how much money they can take. So what we do is you just press Control C, and then you press Control V up here, and you make sure that's a negative. This is going to be 0 now. PMT's unknown, and this is going to be 30 lots of 12. And if we press PMT now, this will come up as a positive number because it's going back to the investor. So it's now 1874.31. 1874.31. So that's how much the investor can withdraw from their super every month if they want it to last for 30 years.